Hello, in today's session, I will go through the control structures in Python. Basically, we know for every programming language, it has the corresponding control structures. To my experience, most programming language, have very similar control structures. Only, it has a little bit difference in the syntax or in the grammar. In the following, I will go through how to use the Python control structures. If you have learned programming in other languages, control structure should be a very simple concept for you. It means how we direct the order of execution of statements in the program. The commonly used control structure include if, else statements, and for and while loops. Also in Python, we have these control structures which are widely used. In the following, I will mainly introduce how to use these control structures in Python, such that our program becomes more versatile and become programmable to solve the real problems. First, let's see the if statement. It executes a group of statements if a certain condition is true. Otherwise, the statements are skipped. This is the syntax in the Python. If condition, this is the condition. If this condition is true, then these statements are executed. Otherwise, these statements are simply skipped. And this is the diagram to show the logic of the if statements. If the condition is true, then we execute the statements under the if condition. Otherwise, we execute the statements after if condition. Let's see this example. We define a variable GPA, assign the value 3.4. If the GPA greater than 2.0, we print these sentences like your application is accepted and congratulations. Note that in Python, unlike other programming languages, we just use the indentation to define the code block of the program block. Like these two lines of statements have the same indentation, so they are belonging to the same block. So these two sentences, these two statements are under this if condition statement. In other languages like C and C++, we may use like the curly braces to define the compound statements of the block. But in Python, this is very simple. We just use indentation. Like this example, if this condition is true, then these green statements are executed. Otherwise, the green statements will be skipped, and we just execute this part of statement. When we talk about the if condition, we usually use the logical expressions using the relational operators. In this table, I list the commonly used operators and the corresponding meanings. Like this is equal. This is the equal condition. If we say 1 plus 1 equals to 2, the output will be true. And here is the not equal, less than, greater than, less or equal to, greater than or equal to. These are very simple operators. We have seen them before. Also, sometimes we want to combine in our condition. We want to include several logical expressions. Like here, you can use and, or not. If none not equal to 6 and 2 is less than 3, yeah, this condition, these two logical expressions are true, and then the final output will be true for the AND operator. Also, when we use the if, sometimes we also want to say how about we want to print something, we want to execute some statements if the condition is not true. In this case, we can use if-else statements. If the condition is true, we execute some statements. Otherwise, we execute some other statements. This is the syntax for if-else statements in Python, and this diagram shows the floating program executing process in Python. If the condition is true, then we execute some statements. Otherwise, we execute another compound statements. Let's see this example. We define a variable GPA with the value 1.4. If GPA is greater than 2.0, we print welcome to Mass University. Else, we print your application is denied. This is a very simple example, but it's widely used when we do the programming, this if-else statements. Also, sometimes maybe we will have multiple conditions. We have condition 1, condition 2, condition 3, or condition, many conditions. For each condition, we want to execute some program, some statements. So very simple. In Python, we can use if, else if, and else, to achieve the multiple conditions. Like this is the syntax. Here we only need to notice, for the else if, in Python, we just write it as ELIF, very simple. This diagram shows a simple flowchart for the multiple conditions. We first determine if the first condition is true. If the result is yes, then we execute some statements. If the result is no, we move to next condition and we determine if the next condition is true or false. If the result is yes, we execute some statements. If the result is no, we execute other statements. By this way, by using this chain rule, we can achieve multiple conditions easily in Python. Here is an example on how to use if-else statement in Python. We first define a list A and which has 3 elements. Then we want to copy elements in A to another list B, such that B has the element values in an increasing order. These are some code snippet I wrote to implement to finish this question. You still need to add some code here using if-else statements. You can try it later and to see how to use if-else statements in Python. Also in Python, we also have the conditional expressions, which is also known as the conditional operator or ternary operator. Ternary operator, if you learned C programming before, you should know there is a ternary operator in C that is the question mark and statement, question mark, statement, and colon and the statement. If the first statement is true, we execute the second statement. Otherwise, we execute the third statement. This is very similar to this is very similar conditional expression as we will see here in Python. This is the syntax: expression, then if conditional expression, else expression 2. This means, if this expression is conditional expression is true, we execute expression 1, else we execute expression 2. For example, here if a is greater than b, then m equals to a, otherwise m equals to b. So here we can also, this is an example. I can run this example in my computer maybe now. Let's see how it looks like. Here we define a variable age equals to 20, for example, s equal to kid if age greater than 80, and else print s. Let's see, age. Yes, if age greater than 18, we print kid. In my case, maybe we should write less than 18. Let's see, as is here. Like here, you can try this, use this conditional expressions by yourself. By using this conditional expression, we can make the code more brief, more compact, which is better when you write very complex programs. Okay. Now there is also pass statement in Python. Sometimes when we write some code, we want to we haven't determined what program we should put for some condition or for some block. We want to finish this code block later or in the future. So now, to make sure your program is running smoothly, you can temporarily put the pass statement there. For example, if true, pass, here it means we may want to write some statements under this true condition, but temporarily we don't know what we write it here, or we haven't determined what we want to write it here. So we can temporarily put the pass statement here, such that the compiler knows that when you execute this condition, we just passed this condition. It doesn't print out anything. This is pass statement. Just help you to run your program more smoothly. You can skip something in your program. Okay, the second main control structure is the loops. Usually we may need to write loops. We want to execute the same block of code many times. In such scenario, we have to write the program using the loops. Using loops control structures. In programming, there are two types of iteration. The first is called definite iteration. This means the number of times that the block will be executed is specified explicitly at the time the loop starts. Like for loops, we will see the for loops, which is the definite iteration. Another type of iteration is indefinite iteration. This means the number of times that loops will be executed is not specified in advance. In this case, the block will be repeatedly executed until some condition is not met, and the typical indefinite iteration is the while loops we will see in the next few slides. Okay, for the for loop, as I said, is the definite iteration. It repeats a set of statements over a group of values. This is the syntax for variable name in group of values and then statements. Variable name gives a name to each value, so you can refer it so that you can refer it the variable name in the statements. This is usually happen. We need to use the variable name in the statements. And group of values can be many different objects. Like it can be a range of integers specified with the range function, a MATLAB, a Python built-in function, or a list, tuple, set, dictionary, or string. It can be many different objects, but these objects should be iterable. Let's say this example for x in range 1 to 6, and then we print this result, like x squared is. When we run this program, we will see the output something like this. 1 squared is 1, 2 squared is 4, and 5 squared is 25. For this range function is widely used with the for loop, and I will talk about this range function more in later slides. Here it shows an example to use the for loop, by group of characters. Like here, this is the variable, this is the group of characters. If we run this program, we can get the output like this. BOO, yeah. Iterating through the dictionary, we can also define the for loops, using the dictionary. Like here, we define a dictionary D, and here, we use the for k in D print k. When we use when we run this part of code, we will get the output something like this. We will print out the key, just the key in the loop in the dictionary. Maybe I can try to run this part of the program to double check. No, it's not working here. Let me how to execute from here and let me type it manually. Maybe that is the easy way. Like we define a dictionary, the key value 1, b k value 2. We write the for loop something like this. Print. Okay. Okay, we can see here, if we run the for loop with the dictionary in this way, we just print, the print just print out the case in the dictionary AA and BB. So if you want to get the values in the dictionary, when you write the for loops, you may need to write in this way, like for k in D, you print like dk, In this case, the output will be the values in the k. Also, sometimes maybe we want to iterate through both keys and values of the dictionary simultaneously. Then you can write the for loop in this way. For kv in d.iterms. d.iterms, it will get the both key and value out and assign them to these two variables kv. For example, if we run this part of code, you will see the output will be this, looks like this. Foo is the key, 1 is the corresponding value. So here, it's a little bit more complex to use for loops with the dictionary. You can practice more to make it such that you can master how to use for loops with the dictionary. Iterators, as basically, when we use the for loops, the group of variables, it should be the iterable object. How to determine if the object is iterable or not? In Python, there is a built-in function iter, I-T-E-R. If we use this built-in function, we can check if the object is iterable. Like here, if we can try this example. Iter this string, and then when we try this part of code, we can see we can get output like this one, iterator. We know this string is iterable, and then there is another function next in the Python. Using this function, you can get the next value from the iterable object. For example, if I try next itr, it will output f. The next itr, it will be o. We can get the value in this iterable object by using the next function. These two functions may be also helpful in your program, but for the basic programming, we really don't need to use these two functions. If you use it in your own projects, you can learn more by searching online how to use them. Okay, the range, every time when we use the for loops, usually we need to use the range function, which specifies a range of integers. Like this is the syntax. The first argument is the start position, the second is the stop position, and it will use this function. It will produce the integers between the start and the stop. But note that the start position is inclusive and the stop is exclusive. Sometimes we may want to specify some step to get a sequence of integers. In this case, we can use the range function in this way. Like the first argument is the start position, the second is the stop position, and we add another third argument that is the step. It produces the integers between the start and the stop, but with the increase of by using this step. For example, if we run this part of program, use this for loops. The start position is 5, the stop position is 0, the step is -1. So we can get some result like this: 5, 4, 3, 2, 1. So the number is decreased, from 5 to 1. You can try to practice how to prevent even numbers from 0 to 100 by using the for loops with the range function to learn, to get more idea about the range function. Some loops incrementally compute a value that is initialized outside the loop. This is usually called the cumulative sum. This is a kind of programming skill you should learn. Like we can compute imagine how can we compute the cumulative summation for a range of numbers. Like we can define a variable outside the loop and which is initialized with 0. Then in the for loop, we iteratively add the value to this variable that is defined outside the loop, and finally we can get the result. This is just a kind of skill for the for loops you should learn. And for the exercise, you can write a Python program that computes the factorial of an integer. This is a very interesting exercise you can practice by yourselves. Okay, the third important control structure is the while loops, which is the indefinite loops, as I mentioned before. It executes a group of statements as long as the condition is true. The syntax looks like this: while condition statements. And this is the diagram to execute the while loops in Python. If a condition is true, we first judge the condition. If the condition is true, we execute the statements. And then after executing the statements, it can give us some feedback. That feedback is used to judge the condition again. If a condition is true, then the statements are continuously to be executed until the condition that becomes false. We execute other statements in the program. This is an example. We first define a variable number stand with value 1. Then we define the while loops. While the number is less than 200, we print out the number, and the number is multiplied by 2. So this part of statements will be executed until the number becomes to a value that is about 200. Like if we execute this part of program, the output will be something like this, 1, 2 until 128. These are some more examples for using the loops. The first loop, I'm trying to use the for loops. Like we use the for loop with the range function. 2 is the start value, 10 is the stop value, and 3 is the step. And here is the for loop. Usually in the for loop we can define some also we can define some variables outside the for loop. And in the for loop, we can compute the summation, a cumulative summation of some values. Uh, in Python, there are keywords break and continue. These keywords are usually found and used with for loops or while loops. Like break, it is used to terminate the loop prematurely. And continue, it stops processing the current iteration of the loop and immediately go to the next round. So these are the difference for these two keywords. The first, break the loop prematurely. The second, stop the current iteration and move to the next loop. Like this here, I try to explain the break and continue keywords and them which are used within the while loop. Like if this condition is true, we execute the statement. Then once we encounter the break keyword, the program this loop will be broken prematurely, and then the program will come to execute this statement. And if there is no this break, assume there is no this break, we can execute the statement to here. Once the compiler of the program encounters this continue keyword, we will go to the next loop immediately without executing these two statements. Also, the break and continue keywords are also used with for loops. This is an example to use these two keywords with the for loops. Like we define for I in range 300 to 351. If I divide 17 equal to 0, this is not divide. We want to get the remainder value. Divide 17, but we want to get the remainder value. If this condition is true, then the whole loop will be broken. Otherwise, the program will continue. You can run this. Here the purpose for this program is to search the first number, which can be divided by 17 within this range. You can try this program by yourself to see if it's working. In Python, there is one more interesting thing we should notice is that Python allows an optional else clause at the end of a while loop and also in the for loop. Like the syntax is like this: while expression statements, else we run some other statements. The else, but here we should notice that the else clause will be only executed if the loop iterates until the conditional statement condition become false. If the loop is accepted by the break statement, the else clause will not be executed. Like for example, this is an example. If this while loop is executed by this break statement, break keywords, this else clause won't be executed only if this while iteration is accepted until this condition become false. This else statement will be executed. Basically, based on my experience, this else clause is not very often used in the programming. I think you can just learn, there is this grammar in Python. If you indeed need it, you can also certainly use it, but usually we don't need to use this else clause. Okay, nested loop. Nested loop are widely used in all programmings. Like under one loop we can define another loop. This is very common to see when we write some algorithms. Like this is an example. We use two we use the nested while loops. This while loop is inside another while loop. The execution for the program is also following the typical procedure as we see before. It doesn't have anything new to for the nested loops, but it's very powerful. We usually for the nested loops, and also break continuous statements are usually combined and used with nested loops. To control the program, how the programs execute. That's very common to be used. Another is in the for loops we can also use the nested loops or loop inside the loop, which has the same concept. First we define a for loop, and inside the for loop we can define another for loop. The execution also follows the typical procedure, as we explained for loops. You can try to practice by yourself if you are not sure how these for nested loops are executed. And also here I suggest some exercise to learn the nested loops. Like first, calculate the sum from 1 to 1000, and second is calculate the sum of even numbers from 1 to 1000. Okay, this session, we learned the basic grammar for the control structures in the Python. I mainly introduced the three types of control structures. The first is if-else statements. The second is the for loops, and the third is while loops. These are very basic elements in the programming. You can learn it very easily, I think.